Giuseppe Donatello, an Italian amateur astronomer, used his keen eyes to find a rare ultra-faint dwarf galaxy on the edges of the Andromeda Galaxy. The nearest big galaxy to our own Milky Way is Andromeda. It is a spiral galaxy that is roughly twice as big. As opposed to the Milky Way's 200 to 400 billion stars, a dwarf galaxy has 1,000 multiple billion stars. Some people believe the Large Magellanic Cloud, which closely orbits the Milky Way and has about 30 billion stars, to be a dwarf galaxy, while others see it as a full-fledged galaxy. It is believed that interactions with larger galaxies have a significant impact on the development and activity of dwarf galaxies. Based on their structure and makeup, astronomers classify dwarf galaxies into a variety of categories. According to one idea, dark matter, or gas containing metals, is involved in the formation of the majority of galaxies, including dwarf galaxies. However, the Galaxy Evolution Explorer space mission of NASA discovered brand new dwarf galaxies developing from low metallicity gas. The Leo Ring, a cloud of hydrogen and helium encircling two enormous galaxies in the constellation Leo, was where these galaxies were found. Dwarf galaxies have been seen to be dragged toward and torn by nearby spiral galaxies due to their small size, leading to star streams and finally galactic merger. Examining archive data that has been processed by NSF Noir Labs Community Science and Data Center, it is most likely a cryptic fossil of the early galaxies, the Pegasus V dwarf galaxy. Following observations by specialized astronomers using the International Gemini Observatory, a program of the NSF Noir Lab, revealed the galaxy to contain very few heavier elements and is likely to be a fossil of the first galaxies. The galaxy was discovered for the first time as part of a systematic search for Andromeda dwarfs. The picture was taken at Cerro Tololo Inter-American Observatory using the Victor M. Blanco 4-meter telescope and the U.S. Department of Energy's Dark Energy Camera, or CTIO. The Community Science and Data Center at Noir Lab used the Community Pipeline to process the data. After that, Pegasus V was confirmed to be an incredibly faint dwarf galaxy on the periphery of the Andromeda Galaxy by scientists using the larger 8.1-meter Gemini North Telescope with the GMOS instrument in follow-up, deeper scans. Half of the International Gemini Observatory is located in Hawaii at Gemini North. Gemini investigations revealed that the galaxy appears to be significantly low in heavy elements when compared to other dwarf galaxies, indicating that it is very old and likely to be a remnant of the very first galaxies to form in the universe. Michelle Collins, an astronomer at the University of Surrey in the UK, and the paper's primary author, said, "We have uncovered an incredibly faint galaxy whose stars formed very early in the history of the universe. This finding is significant since it represents the first time a galaxy this faint has been located around the Andromeda Galaxy using an astronomy survey that wasn't intended for the purpose. The first galaxies that formed are thought to have left behind only the faintest galaxies, and these galactic remnants hold information on how the earliest stars were created. The number of dim galaxies like Pegasus V that astronomers anticipate to find in the universe is far less than what their models predict. If there are actually fewer dim galaxies than expected, this raises major questions about how well cosmologists understand dark matter and the universe as a whole. Therefore, finding instances of these dim galaxies is a crucial yet challenging task. In large photographs of the sky, these faint galaxies seem as a few sparse stars buried, which adds to the difficulty in finding them. The problem with these very faint galaxies, according to Emily Charles, a PhD student at the University of Surrey, who was also engaged in the study, is that they have relatively few of the bright stars that we generally use to identify them and gauge their distances. We were able to quantify the distance to Pegasus V and discover that its stellar population is exceptionally old because to Gemini's 8.1-meter mirror's ability to discern faint, old stars. An astronomical term for a tiny galaxy with numerous huge clusters of young, hot, massive stars is a blue compact dwarf galaxy, or BCD galaxy. The galaxy itself appears blue because of these stars, the brightest of which are blue. Dwarf irregular galaxies and dwarf lenticular galaxies are further categories for the majority of BCD galaxies. BCD galaxies are irregularly shaped due to the star clusters that make them up. Their tremendous gas consumption during star formation results in extremely violent stars. During the process of producing new stars, BCD galaxies cool. Because the stars in the galaxies all originated at various times, the galaxies had plenty of time to cool and accumulate material to create new stars. This star formation modifies the galaxy's shapes over time. The universe's faintest galaxies are known as ultra-faint dwarf galaxies, or UFDs, a class of galaxies that only have a few hundred to a few thousand stars in them. UFDs look similar to globular clusters, GCs, yet they have very different characteristics. UFDs are more extended and have a higher dark matter content than GCs. UFDs were initially identified in 2005 with the introduction of digital sky surveys, specifically with the Sloan Digital Sky Survey, SDSS. The known systems with the greatest dark matter dominance are UFDs, since all known UFDs are ancient systems that likely formed very early on, just a few million years after the Big Bang and before the epoch of reionization. Astronomers believe that UFDs contain important information about the early universe, a population of young UFDs that originate considerably later than the ancient UFDs may exist, according to recent theoretical studies. So yet, these galaxies in our universe have not been seen. The 2000s saw the discovery of a new class of highly compact galaxies known as ultra-compact dwarf galaxies, or UCDs, which have extremely high stellar density. They are estimated to be around 200 light-years across and to contain 100 million stars. Theoretically, these are the centers of nucleated dwarf elliptical galaxies that have passed through the centers of rich clusters and been stripped of their gas and satellite stars by tidal interactions. UCDs have been discovered in a number of clusters, including the Coma Cluster, Fornax Cluster, Virgo Cluster, and Able 1689. The next-generation Virgo Cluster Survey team has discovered an especially substantial sample of around 100 UCDs in the Virgo Cluster's core. UCDs are thought to have unique dynamical and structural characteristics from regular globular clusters, according to the first relatively reliable analyses of the global parameters of Virgo UCDs. M60UCD1, which is 54 million light-years away and has 200 million solar masses in a 160 light-year radius, is an extreme example of UCDs. Its central region has stars that are about 25 times closer together than stars in the Milky Way region where Earth is located. M59UCD3 is roughly the same size as M60UCD1 and has a half-light radius, RH, of 20 parsecs. However, it is 40% more luminous and has an absolute visual magnitude of 14.6. This makes M59UCD3 the densest known galaxy. Two UCDs in the Virgo cluster are thought to have supermassive black holes that are 13 and 18% of the mass of the galaxies, respectively, based on stellar orbital velocities. Pegasus V may be a remnant of the earliest galaxies, according to the team's strong concentration of old stars there. Pegasus V seems very old and metal-poor when compared to the other dim galaxies in the Andromeda region, indicating that its star production ended quite early indeed. Collins stated, "We expect that future investigation of Pegasus V's chemical characteristics may provide light on the earliest stages of star creation in the universe. We might learn more about how galaxies originate and whether our knowledge of dark matter is accurate thanks to this little fossil galaxy from the early universe." According to Martin Still, Gemini Program Officer of the National Science Foundation, the public access Gemini North Telescope provides an assortment of opportunities for community astronomers. In this instance, Gemini helped the worldwide team to establish the existence of the dwarf galaxy, link it to the Andromeda galaxy physically, and identify the evolved stellar population's metal deficiency. Future astronomy facilities should provide more information about dim galaxies. Reionization is a period in the history of the universe that Pegasus V witnessed, and NASA's James Webb Space Telescope will soon detect other objects from this period. In the future, astronomers intend to use the Vera C. Rubin Observatory, a program of the NSF NOIR Lab, to find additional dim galaxies of this nature. The Legacy Survey of Space and Time, an unprecedented 10-year optical sky survey, will be carried out at the Rubin Observatory. Thanks for watching. If you enjoyed the video, hit the like button and subscribe to the channel. Until next time.